Hello everyone, Mr. Minix, my name, math is my game. Today, in this lesson, we're talking about TI topics, and we're talking about systems of equations. Just a quick 30-second crash course on systems of equations. You're going to have two equations. You graph one and you graph the other. And if you graph the one and it ends up looking like this, that line should be solid. Don't know what happened there. Let's try that again. Well, it's not, but anyway, you get the idea. So we graph one line, and then we go ahead and graph another line, and maybe the lines meet. And if the lines meet, there's a solution to the system. Remember that? And the solution, then, is the ordered pair that denotes the spot in whatever coordinate plane that the lines meet. And something special then happens if the lines don't meet. What do we say if the lines don't meet? What do we say? If the lines meet, there is a solution. If the lines don't meet, there's no solution. That makes sense? And sometimes lines are the same line, and there's a special way to represent if we have two lines that happen to be the same line in disguise, and we'll talk about that. Okay, so we got 4 examples to get to. We got 3 different ways of doing this. Remember, all week long we've been using the graphing calculator, and we'll briefly look at doing these by hand. So our first example has this system. Maybe you want to jot that down. The one equation is negative 2x plus 3y is equal to negative 8. The second equation is 5x minus 7y equals 1. And in my classroom, I'm going to take a minute and write that on my chalkboard on the side. So that's negative 2x plus 3y. I don't have a chalkboard. It's a dry erase, but same idea. Equals negative 8. And 5x minus 7y is equal to 1. So in chapter 2 or 3 somewhere, we used matrices. And the whole idea of a matrix is it's a rectangular array of numbers. And in our matrix, in the first row, is going to go this first equation. And all we're going to do is put the coefficients, just the numbers. So in that top row, we're going to have the number negative 2, the number 3, and the number negative 8. Following that logic then, in the second row of our matrix, we're going to just use the coefficients of 5, negative 7, and positive 1. And what we're going to do to that particular matrix is there's a command called reduced row echelon form. It's like a magic trick on matrices. It's like abracadabra, alakazam, take this matrix. I don't know how to end that without cussing. I almost said the D word. Anyway. So what we're going to do is we're going to RREF that, and the calculator is going to return this matrix with a 1 here and a 0 here and a 0 here and a 1 here. And whatever this number is, that's part of our answer. Whatever this number is, that's another part of our answer. Our answer is going to be whatever's in the circle is going to be our x-coordinate. Whatever's in the square is going to be our y-coordinate. And that's it. It's real easy. It's awesome. This should go super duper fast. It's contingent on you being able to punch that right stuff into the calculator. Think you could do it? Good. So let's see if we could do this then. On our calculator, remember, we don't want to use the scratch pad. I see people using it. Don't use the scratch pad. We're on a calculator page. If you don't know how to do that, start a new document. Home, 1, new document. Don't save the old one. And we're just going to a calculator page. A calculator page. The command RREF, you can just type that on the ABC keyboard. Just type R, got to have 2 R's, EF. I said RREF. Notice that the command will go from italicized to not italicized because it's a recognized command. So the next thing we got to do is bring up a matrix, and that's done by using our Math Palette button. If you're not sure what I'm talking about, there's a button right next to the number 9 that has your Math Palette on it. We'll press that. It seems as though I've used this a time or two. Do you see the second row down, the 1, 2, 3, 4, 5, the 6th thing in, that 3 by 3 matrix? You're going to have to click on that. You're going to have to click on that. Now, we don't want a 3 by 3, but we're going to need to use that 3 by 3 to do what we got to do. So we'll go ahead and click on that 3 by 3 matrix, and we actually want a 2 by 3. We want a 2 by 3. So the number of rows we'll say is 2. The number of columns we'll say is 3, and we'll click OK. And now we just plug in our numbers. -2. I like to use the tab, the TAB, the tab button to cycle from cell to cell. So then we got the 3, and then we got the -8. Tab will get you down to the next row also, and then the 5, and then the -7, and then the 1. How we doing so far? Okay? Cool beans. So we're just going to press enter, and it says I'm missing a parenthesis. Dang it. Okay. Okay. I forgot the parenthesis. My bad. I'll neck myself. So the parenthesis needs to go between the RREF and the matrix. So I put my cursor in between RREF and the matrix, and I'll put a parenthesis, and now the calculator will give me the answer. So the calculator returned what I thought it would, and now we just got to interpret the answer. We just have to interpret the answer. So let's put this on this current page here. So what's our answer? What's our x coordinate? The x coordinate's not 1. The x coordinate is, -53, and then the y coordinate is -38. What this matrix says, what this top row really says, this really says 1x plus no y is equal to -53. So in other words, it really tells us that x equals -53. Similarly, the second row tells us 0x plus 1y is equal to -38. So it's really telling us y is -38. So our answer is the ordered pair -53, comma, -38. And that's about as simple as it gets, right? Isn't that the bee's knees? The horse's pajama, the cat's meow. Okay. So one little caveat about these. Notice what kind of form both equations were in. Remember yesterday we talked about the different forms of equations. Both equations are in standard form. If your equations aren't in standard form, you got to be careful. Okay. Cool beans. Let's look at the next one. The next one we're going to solve by graphing and or using LinSolve. So I'm telling you that we could solve this by graphing, so if you had to graph this by hand, you probably could. And on Friday's test, there might be a system you're solving by hand, because maybe you forgot how to graph it on the calculator. Maybe you forgot how to use the LinSolve. This first equation has a y-intercept of -5 and a slope of 2, and I'm just rising and running, and rising and running, and rising and running after I plot my initial point. And hopefully if I rise and run enough times, I'll see the answer pretty clear. This other one has a y-intercept of 4 and a slope of 1/5, up 1 and over 1, 2, 3, 4, 5, and there it is. Didn't take that long to get to my answer. So my answer to this particular system is that point right there. It looks like 5, 5. But we're looking at how to use the graphing calculator to do this. Could you solve that on the graphing calculator by graphing? Hopefully you could. So remember, on the calculator, there's no need to start a new document every time, but I am going to go document, and I am going to insert a new problem. I'm going to insert a problem, and I want to look at a graph. I said graphs. And my first equation is y equals 2x minus 5. So I can just go with the 2x minus 5. My second equation, I press tab to bring that up. My second equation, I'm going to start with the fraction bar. It's 1/5 x plus 4. I got to make sure I put the plus 4 in the right place. Plus 4. Whoop, I didn't put the x in the right place. That makes a big difference. Makes a huge difference not putting the x in the right place. 1/5 x plus 4. There's that. And one thing that's going to help on this, I probably mentioned this earlier this year. If I could somehow turn on a grid, it would be very helpful. And to do that, I'm going to press Menu. I'm going to go to View, grid, lined grid. Menu view, grid, lined grid. And that makes it pretty clear where my answer is, I think. But if it doesn't, what I could do is I could also go menu, and I'm going to put on my special eyes, my anal eyes, and I'm going to find the intersection. And this is the part I think that's really difficult in the calculator. It's asking you for three things. Well, actually two things. It's saying lower bound. You have to have that cursor somewhere to the left of the point that you're trying to approximate. You're trying to approximate that point, and my cursor is to the left of it, so I'll go ahead and press enter. And it's saying upper bound, so I need to drag my cursor over. I need to drag that line over so that it's on the other side. Maybe it's not going to work over here. I need to drag my cursor so it's to the other side of that. And it's kind of tricky to do. My calculator and my smartboard don't play well, so I'm going to try that process again. Analyze graph, intersection, lower bound, I click right there. Upper bound, I need to drag the cursor over, and I click again, and there's my 0.55. How do we feel about that process? Okay? If you don't like that process, there is something else that you could do, and it's called LinSolve. Now, I got to be honest with you, I would not type the command LinSolve. That's too much work. But what I would do is I would go to Doc, insert a calculator page. And from the calculator page, unlike last time we used matrices, we're not going to use a matrix on this, but we are going to use LinSolve. We're going to go menu, algebra, solve system of linear equations. There's two equations, the variables are x and y. We'll click OK. And we can punch in both equations just as they appear. And we're going to have to type these with our keyboard. Y equals, it was 2x minus 5, I believe, right? So y equals 2x minus 5. The second equation is y equals, fraction was 1/5. X is on the side, and then plus 4. So the cool thing about this LinSolve is it doesn't matter what form the equations are in. They don't have to be in standard form. One could be in standard, one could be in slope-intercept. The form doesn't matter. All we got to do is just type the equations in right, and there it is. Boom, 5, just like that. There is a drawback to this LinSolve, and we'll see it in the next example. Well, not the next one, but the last one. We're almost done. Does anybody have any questions for the good of the order so far about anything we've seen? Okay. Well, we got two more examples. Here we go. Example 3, we're going to try to solve this with LinSolve. Y equals 3x plus 4, y equals 3x plus 5. So same thing, menu, algebra, solve system, two equations, x and y. Our first equation we said was y equals 3x plus 4. And our second equation we said is y equals 3x plus 5. Does anybody think they know what's going to happen here on this one? You should be able to recognize something about those equations. Y equals 3x plus 4, y equals 3x plus 5. What are the slopes of both of them? The slopes are 3 on each one, right? So they have the same slope. In geometry, what did you learn about lines with the same slope? That they are parallel. Do parallel lines intersect? So does this have a solution? Boom, no solution found. So you probably could have known that if you just thought about slopes. You probably could have known that before you even had to punch in anything there, right? So if you ever took a handwritten test in a college algebra class, or even in my class, I would take it a step beyond. Rather than just saying no solution, I would take it a further step and say parallel lines. You know, there's parallel lines here. No solution's right. They're not going to meet. And we have parallel lines. Okay. So we just got one more example, and then that's it. And this is probably going to be new to just about everybody, this last one. So this last one, I'll go ahead and write this on the chalkboard. This last one, we got 3x plus 5y equals 15. So that first equation is it's not exactly in standard form, but it's pretty close. The second equation is y equals negative 3/5 x plus 3. And that's in slope-intercept form. I probably wouldn't want to use a matrix because I'd have to put the one equation in standard form. Probably wouldn't want to graph because there's too many buttons to press, but this LinSolve is awesome. I like using it, so let's try it. Menu, algebra, solve system of equations, two equations, x and y. Here we go. First equation, 3x plus 5y equals 15. Yeah, knowing this information that we are going through today would have been handy to know in geometry and algebra 1 for sure. 9th grade year too, for sure. For sure. So our second equation, we got y equals negative 3/5, negative 3/5 x plus 3. Let's take a look what happens here. We got, for our answer, 5 minus 5c1 over 3. And c1, does anybody know what on earth that even means? It looks really unusual. I have no idea what does that even mean? 5 minus 5 times c1 over 3 and then c1. Looks really weird. So as good as the calculator is, there's some times where you're going to have to use your brain, where you might have to know something else. It means many solutions, because if you were to take this top equation, 3x plus 5y equals 15, and subtract 3x from both sides, you'd see that we have 5y is equal to negative 3x plus 15. And then if you divide by 5 and divide by 5 and divide by 5, what you would end up with is y is equal to negative 3/5 x plus 3, which is the same as that equation. They're the exact same line. So there are many solutions. Nice job. There are many solutions. And this is what's new. Here's how we represent the answer. Our answer is written this way. It's the set of all ordered pairs x's and y such that. This is the way we write. There's many answers, and the answers are any point on the line. What line? Take your pick. Do you like this equation or do you like this equation? Which one would you rather write? First one, top one, and second one. Top one? Okay. So when we write our answer, we're going to write it this way. And what that literally translated means is that our answer is any point on that line. There are many of them. There's an infinite number of answers, and it's any point on that line. In Algebra 1, it was good enough to say there's many answers, but this is varsity math, son. That's what you got to write. Literally translated, this means our answer is the set of all ordered pairs x and y on the line defined by the equation right there. Okay? So our answer is every single point on that line. And what we have is coinciding lines to the same line. Okay? How do we feel, all right? Does it matter what equation you put? No, you could have written in the place of that, you could have written y equals negative 3/5 x plus 3 if you would rather write that. Either way, because they're the same, they're at equivalent form, so either one's fine to write. Excellent question. Any other questions, comments, concerns, short debates? Well, it's been real, and it's been fun, and I hope it's been educational. See you. Good. Remember the worksheets due before you pass out.